Hi, everyone. Welcome to today's Snapshot. It's a pleasure for me to talk about StableNet and Agentic AI. Today I want to give a quick introduction to the topic and show a little bit my setup and some use cases I've already been working on. This is for sure not the last video on that topic. We will have future tutorials coming up, maybe some blog posts, so there will be definitely also more content coming. Normally, these snapshots we do completely without any PowerPoint slides, but for the sake of showing a little bit more in less time and also overcome the few minutes the AI is somewhat sometimes taking to calculate a result, I decided to show this in combination with a few PowerPoint slides. So for that sake, I will keep the beginning very, very short, not spending too much time pitching why this is actually needed. I think it's quite obvious. It's cool to talk in natural language to your system rather than having to type a lot, rather than having to click a lot and to use a normal interface. It's also cool to accelerate operations in the sense that if you want something more and you are requesting for more details, you don't need to like find the right spots to click and the right steps to do yourself, but it's like having someone sitting next to you who is actually doing that for you. So you just tell the AI what you want next and it's doing it. After all, it then also helps with generating code, validating things. So it just simplifies life so that on the long story, or also correlating different things and bringing things together, you can then reach more autonomous workflows, even better automated than before, ideally. And on the long run, save effort, get quicker MTTRs, and have a better life and more time for what you actually want to do. And with that, going directly to my setup and what I've been doing. So what I'm showing next is actually what is run locally on my local machine. I'm glad that when getting a new MacBook, I was lucky to choose one with a little less processor power, but therefore more RAM, which is actually great for the silicon architecture of Apple because it gives me the possibility to run quite large language models on my system locally. Probably what I'm using currently would also run on 48 gig or 64 gig. And very, very roughly, my setup for the technical people here to understand is that I'm running my large language model directly on the host system because this is where I benefit most from the MLX architecture from Apple, whereas I'm running my actual Claude Code Agentic AI on a Linux virtual machine in order to completely sandbox it and not to reach the outside world. And that means in more detail that on my Mac, for those of you who notice a little bit, I'm using an open source model Qwen 3.5. And I'm actually on my Linux VM, which is a normal Ubuntu setup in a few minutes, basically maximum a few hours. I'm installing a Claude environment and connecting it with the right environmental variables to actually not contact any public server, but to contact my local Olama system with the locally running Qwen, so it's completely local. And in addition, I have a proxy server, which is actually delivering access to the StableNet server, which is located at the InfoSim base. So that way, I'm not having direct access to StableNet, but I'm only talking with Claude. Claude is only talking to the proxy server. It does not even see the normal IP address of the server, does not see the username, but it's just talking to that proxy, and everything is handled by that proxy. And that gives me also additional security things. So the StableNet server is easy to prepare. It's just any normal StableNet server with the REST API being licensed. And in addition, I'm having a read-only user that in my case is called read-only Agentic AI. And it's actually hard-coded in my proxy. So this is the only username I support at this point, but this is intended in order to not give Claude any possibility to try accessing the server with any other user. The network details, I will skip those for the sake of time, but basically, as I said, it's all running on my Mac OS with a bridge to the Linux VM and then going to the server in the local network. And quickly on the security, Claude Code is fully sandboxed. As I said, it cannot reach the company network, cannot reach the outside world, so it can't do any harm. Even if it would go mad, it couldn't do anything for the sake of not having access. I can't access the server directly, but only via the proxy. So Claude doesn't even have to know the IP address of the server or anything. You can completely keep that obscure. You can also further restrict the proxy to only do, for instance, get, post, and put. We need a read-only access user on StableNet, as I said. And as a nice extra benefit of the proxy, I can also rate limit the request. So I can say maximum 10 requests per second. So that way I'm making sure that Claude wouldn't go mad. I mean, maybe Claude itself wouldn't, but there could be some prompt injection, which is actually telling Claude to do a denial of service attack on my StableNet server. So I can completely avoid that by basically having a rate limiting in my proxy, and it just doesn't allow more than 10 requests per second. And I'm also logging all the access to my server, so I will exactly know what Claude actually tries to do with my server. That's my setup. A quick look for the technical people, a quick look into the proxy, not showing the full thing here, but just giving an idea of it. It's a black box Python script, which is specifically intended for the agent. It handles the authentication to the server implicitly. So the Claude doesn't need to know anything about this. It's rate limited, as I said, and it's technically limited to REST calls to the REST API, the XML REST API, as well as to the servlet calls for some statistics and so on. Now I go and start my Claude. And in order to do this, Claude needs some kind of basic information. This can be very limited and doesn't need to be a lot. And what I actually do is I have one markdown file, claude.md, which is the standard file name for Claude in this case. And I'm basically just telling it that there is a tool that can be used as a proxy for the REST API of StableNet, that it's the base, it's telling the base URL, it's telling what it can do and can't do, it's telling it how to invoke it with curl. It's telling it that the authentication is implicit and also that it's rate limited, so it should paste the requests accordingly. And of course, also efficiency makes sense rather than doing just broad dumps all the time to keep it on a limit. What you are seeing here is not the full Claude MD, but you can see here on the right side the outline of the full Claude MD. So I also provided in that file, what I'm not showing here in detail, I provided some common API endpoints. I didn't come up with this by myself, but I basically had a larger public model where I threw in the PDF documentation of the StableNet REST API, and I said, please pull out the most important information for me. And it gave me basically a summary in Markdown that I put into my Claude MD file. So this is AI prepared. And I also, of course, I had a second look at it, that it makes sense. And I also put some information about legacy servlets based on the documentation, as well as some references to further information if needed. And that's basically all I started with. And now let's come to the point where I actually start my Claude code. I started locally, as you can see. It's running local with my Qwen 3.5 35B. And now I'm actually entering my first prompt. So this is a prompt I put in. Check the key endpoints of the StableNet server, devices, connections, measurements, weather maps, jobs, and open alarms. And I just hit enter, no other information. The only thing it has basically is my claude.md file. And it directly goes ahead and tells me I'll check the key endpoints of the StableNet server by making HTTP requests. And it starts asking me, can I do curl? I say, yes, curl is allowed for this session. So it goes ahead and does REST devices list. For those of you who are familiar with the REST API, all of this will seem very known to you. REST connectivity, REST measurements, REST weather maps, REST jobs, REST events, open alarms. Please remember that beer emoji here. I will get back to that. So there's one alarm with a beer emoji. And then it says, all key endpoints are responding. Here's a summary. And now comes the interesting part. It's not just checking the information based on what it knows, but it's also directly putting some intelligence and summarizing it, categorizing it, telling me, for instance, that there is a 6.9 megabyte response of XML for devices, which is more than 1,000 devices with different text interfaces and so on. Same for connectivity, telling me how large the file is, what is in there. Same for the measurements. And then also for the weather maps, it's telling me it actually finds no weather maps, which is due to the fact that the read-only user doesn't have access to that in my setup. Same for the jobs. There's no access to jobs, so the list is empty. And last but not least, there are also open alarms in different states. So this is already the next thing. I did not put anything about that in my Claude MD file, but it's able to not just pull the data, but to directly put some intelligence to it and to create a summary. It's also providing me here some summarizing comment, like devices, connectivity, measurements, and open alarms. Addressing here a few of the points, like for instance, the test alarm. And then it tells me also where to get more detailed information. By the way, all of this took like 2 minutes on my local laptop in this case to run this. And now I just want to show one more thing. So I went ahead and I said, if I'm not mistaken, I have seen an alarm with a beer emoji in the text. Can you double check that? And if yes, provide more information. So the AI goes ahead and said, let me search the open alarms response for the beer emoji. It's not actually getting for me like a pattern that it can match, but it's just getting the word natural language beer emoji, but it does the job of actually saying, yes, confirmed, there is indeed an alarm with the beer emoji. Here are the details. So it first provides the details that it can get out of the alarm directly. And then it says, let me fetch more details about the device. And so the device ID is 1030. So it actually goes ahead by itself and does a curl on REST devices get 1030 to get more information. I cut away here a little part of the intermediate process, but at the end, basically I get here's the full information about the alarm with the beer emoji. There was no prompt in between. So this directly happened after a little while. And it is telling me actually all the details here with whatever it got from the REST API put in a nice table. And finally, it's also providing me the device details. I removed here just for that webinar, I removed the name of my colleague, but actually this is also a part of the device information. And then it's also telling me some interpretation, which again, I did not give any background information, but it's intelligent enough out of the box to say, hey, this is probably a test alarm, which is indicated by test alarm in the info field. That has been created. Likely it's for Alexa integration testing, given the German phrase für Alexa, which means for Alexa in English. And the beer emoji is probably a celebratory touch. So it also does that link. It's not matching a pattern, but it's having some kind of semantic understanding of that. And it's also telling me that the alarm has been active since March 2024, which is like an indicator that it's probably outdated. Again, this case took here like 2 minutes and 51 seconds. And now for the sake of time, I don't want to show so many more of these examples in my console directly. But what I actually did to Claude, once I was done with my demo, I told Claude to please do a summary in an HTML page where I can actually show a few more prompts and what was the outcome. And with that, I created a nice interactive web page. To be honest, I had another AI help me to do the final push to it. So the final touch is not completely Claude locally, but there was a public API involved at the end to make it visually nice. But like, let's say 90% of that is directly out of Claude and the rest of the HTML is coming from a public AI. And then now you should be seeing my browser instead. And here actually, I'm now showing this web page. And I will just show a few more examples based on this HTML. So I have shown you this example, check the key endpoints of the StableNet server, and it delivered me here, after checking all the endpoints, it delivered me a comprehensive summary and some interpretation here. Then I did the beer emoji thing, and it actually told me all the information about the beer and the celebratory touch and so on. I also tried asking for jobs. So as you have seen before, there was no job allowed for the read-only user. So in the meantime, I had allowed access to exactly one job. And after doing this, it said, are there any jobs on the server? And it actually said, let me check the jobs endpoint again. Now I see it, there's one job configured and I get some information about the job. Let me get more details about this job. So I get more details. And it also is telling me this is a discovery job that was created for energy data collection, but it's currently inactive. The trigger window has already passed and the job is disabled. So it's not just providing information, but also providing some kind of interpretation. Hey, this might be outdated or at least inactive. I did the same thing with weather maps, but it kept telling me, let me check the weather maps endpoint. The weather maps list is empty. So it did not tell me anything about weather maps because it couldn't. But it again proposed me some alternative information that might be interesting for me. Then I asked for reports. What about reports? You can see my prompts are very short. So I intendedly don't put long prompts because I want to check what it can do with short prompts. Of course, the longer you put prompts, the more probably you can help it to do the job. And then it's telling me, let me check for reports, blah, blah, blah. There are 7 reports on the server. So I get some information about that. It's again summarizing this, getting some more details and telling me about that these reports, for instance, are not regular reports, but single trigger reports and so on. And maybe finishing slowly. I also did that one here, alarm management email provide a comprehensive overview email to the management based on the current alarm states. I want to be able to directly copy paste and send it. And after a few minutes work, it actually came up with a complete email with a subject line and then a complete email text with an executive summary, alarm severity breakdown, critical alarms, alarm category breakdown. This is not based on existing tags in StableNet, but this is an additional interpretation that the AI has been doing based on what it found on the server, categorizing this. Talking about affected infrastructure as well and the linked devices. And finally, coming up with recommendations, what should be done. For instance, immediately review and clear the test alarm for Alexa, as it has been active since March 2024. And finally, it ends up with a current date, which is taken from the Linux console. So it's also knowing when it is running. And it's proposing to do the next schedule review daily at 9 a.m. The only thing which doesn't make sense is that it's pointing the management to click to a local host address, which of course doesn't make sense, but that's like the only obvious error I could spot. Other than that, I would say it's like 99% ready to go. And then I had some fun and said too long, didn't read. So I got a shorter version of it right away after. And finally, and that's my final thing to show today, finally I said, memorize the steps you conducted to reach this result and prepare a single file minimal script to do this every week automatically. And what it actually did is it completely automatically wrote, in this case, a shell script for me, which you can see here. So this is the shell script. I won't go into the details, but basically it's quite simple. It's having the URLs, it's calling the URLs, it's putting together a text. And that it saved this shell script on my Linux sandbox. And then it also wanted actually to set up a weekly cron job. I didn't allow it to do that, but it proposed me to directly set up a weekly cron job that runs every Monday at 9 a.m. to automatically generate this. And with this, I want to come to an end for today. I think given that I have only provided a wrapper to the StableNet, a proxy wrapper to the StableNet API and a small Claude MD file without too much information, I think it's quite impressive to see what can be done like this out of the box. And I'm looking forward to do more like this, to work with more complex markdown files, to maybe introduce some kind of MCP server concept. And I'm also looking forward to have exchange with anyone else who is trying this out and having their use cases to discuss about what we can do together. Thank you very much.